All right, let's do this one. So, do we have an answer? Okay, awesome. So, what end behavior was it? Up and down. Very good. But where does and? Okay. Up and down. So, like this. So then as x is approaching positive infinity, f of x is approaching negative infinity. I always have to draw a picture to make sure I get it right. As x is approaching negative infinity, f of x is approaching positive infinity. Don't miss that one on the stage. Okay, all good? Next one. Find the inverse and state the restrictions for practice. Ready, go. Right. Gotcha, that makes sense. Okay, let's switch x and y, right? Were you guys all able to do this one? So x equals -5, and then y minus 3. Solve for y, so you'd multiply by y minus 3 to both sides. It divides out. And then you would divide by x. So we have y minus 3 equals -5 over x, and then you'd add 3. So we're going to write it correct. Oh, yeah. So y is equal to -5 over x plus 3. So x cannot be 0. All good. Very good. I think we just only state this one's restriction. Well, I don't know. Let's think about it. Like, we definitely know that we're not going to have an x value of 3 here, right? So the restriction up here is, yeah, x cannot be 3. And then you see how down here, our restriction 0? But it can equal 3 down here, and it will equal 3 down here. So we won't state that one. Because if we were to graph this, it's all good at 3, right? Yeah. Okay. Oh, you know what though? Let's see. Geez, I can't think today. So, it's not that it, because here's the thing, it can cross the, if we are going to have an asymptote, aren't we, at +3? Think back to graphing rational functions. So the, this isn't linear. Rational. Well, it shifted up 3, correct? If it was just 1 over x, its original asymptote is that we can't be at 0. So now it's shifted up 3. That's what we're trying to think about. So then remember to find this vertical asymptote, it can't be on bottom, so it also can't be 0. This is what? Is this vertical? Yeah. So our vertical asymptote is what we can't divide by, so we're going to have a vertical asymptote at this. We get our horizontal asymptote by doing the top. Oh, wait a minute. What? Geez, I'm struggling. So this is what our graph would look like. Our restriction would just be x cannot be 0 because it will eventually be pretty much 3. 3 is fine. So this would be our final answer. Okay. Create an equation for how to solve for variable n. Use your algebra skills. Go. Get this one right. Don't make weird. Yeah, basically. Oh. And so look and see if you did it different. If your answer is the same as mine, there's many ways to get there. Okay, so then also a lot of people want to just say, oh, well, they're all over 1, so we can just split the fractions. It doesn't work like that because of the addition sign. You can't do that. Okay, so I guess since I'm trying to solve for n, I guess I'm going to do my first step. I'm going to subtract this over. So I have 1 over r minus 1 over m equals 1 over n. Everybody good? Then from there, I'm going to say, okay, I need to have just one fraction over here, so I'm going to get a common denominator. So I'm going to multiply by m over m, r over r. So then that would be m minus r all over mr equals 1 over n. Is everybody good? Now, this is when it is okay to flip your fractions. If you have a fraction divided by a fraction, so you see how they're not split up? It's one fraction equals one fraction. It's not split up into two fractions by a subtraction or addition sign. Then you can flip both sides. So on top here, I have m over m minus r equals n over 1. So didn't we solve for n? So just curious, did yours come out the same? Yeah. Okay, cool. So they got their different way, and I just wasn't seeing what they were saying. So I'm like, you know what? I'm going to go do it this way, and if your answer's the same as mine, then you've done it right. You haven't broke any algebra rules. So good. Perfect. That makes sense now, what you're saying, though. Now I'm seeing it because I did the problem. You've got a common denominator straight across, and so then it cancels out. That makes sense. Yes. Okay. Anybody have any questions? So, okay. They got a common denominator amongst all of these. And then they just cancel out the denominator because, well, if we're solving for something, yes, because all the denominators were the same then. So then they just, after that, then took the top and solved, and it came out the same. Hey, here you go, number 4. I wanted to give you a chance to do it by yourself. So I'm going to figure out what the original period is, but make sure you don't think that's period, right? That is not our period. Period is 2 pi for cosine, 2 pi divided by b, so that would be pi halves. So we need to cut our period in half, so that's pi fourths. So now I'm going to work backwards. I'm going to say, but that's not what goes in the equation. B is, so pi fourths is our new period. That equals to 2 pi divided by b. Now I'm going to solve for b. So I'm going to multiply by b, multiply by 4. So that's b pi equals 8 pi. And I'm going to solve for b, so b is 8. All good? Did you get that? Yeah. Nice. You guys are so smart. 8, and then twice this would be 6. Oh, it says half the amplitude? No, it says twice the amplitude and half the period. Wait. 6 cosine of 8 theta.
I was literally watching.
Okay, what's the question?
I don't know.
So that's the number of cycles from 0 to 2 pi, right? That's not period, though. So our period is 2 pi divided by that. So I said, well, if it's half the period, I need to even figure out what the original period was. Okay? So my original period was 2 pi divided by 4, which is pi halves. Does that make sense? And I said, well, we want half that period, so I divided that by 2, which is pi fourths. So that's our period for the new one. So we know that period equals 2 pi divided by b, solve for b. 8. Okay, go for it. This is what we just tested on, and this is what I have seen in previous years. So I drew up my normal distribution, and then I'm trying to, so we're running into the question of, well, what the heck, 44.2, where does that really fall down here? And then Ali makes a good point. That's literally halfway between here. Halfway between these two values. Does everybody see it? So I'm going to kind of go like this. So that's the 44.2. So I'm going to cut that percent in half. So because it's the halfway distance, that's exactly what they're wanting you to do, is think a little bit deeply about this problem. So then our percents are, it says a diameter of 44.2 or larger, so that would be from here up. So add up those percents. So you'll do 13.5 divided by 2. So 6.75% plus 2.35% plus 0.15%. That's how many percent we can expect. Okay, so 9.25% we can expect. Now that's not our answer. It says out of 300 balls. So you'll take 300 times 0.925. That's how we figure out the percent. Oh, yep. Otherwise, that would be 92.5. 300 times 0.0925. So we should expect 27.75 balls. I don't know the correct answer to that, if we should be rounding up or down or whatever. I think you might round down only because you're right. If we have 0.75 a ball, we'll just not count that ball. I think, I don't know, to be honest, what they were going to want you to do. 27 is my best guess as well. Okay, next one. Good thinking. 6. Graph this problem. Negative f of x is a reflection over the x-axis. So up to, so shifting for all functions works the same. It's a shift of up to, and then there's our starting point. So there's no shift left or right. And then, that's a reflection over the x. So normally it goes up like this, so it's going to go down like this. You'd want to plot exact points. If you needed to, you could plot points, but I'm just hoping that we wouldn't need to. But I mean, you can plug in things, right? Obviously, if we plug in 0, we'll be at 2. If we plug in 1, that would be what? 1 over 1 up 1, so it's looking like this. And anyways, it's going to cross. If we plug in 2, it's a decimal. 3, it's a decimal. If we plug in 4, won't that be 0? So at over 4 up 0, somewhere it's going to right there. That'd be 4, for example. You'd want to plot exact points. Everybody good? Yeah, so it normally would have looked like this, but then we reflected it over the x-axis because of the negative in front. So.
Wait, but we didn't actually flip over x-axis.
No, we didn't. A reflect over the y would be over here.
No, I didn't mean y.
Okay, like if there was no shift to 2, it would have dropped it over that. So should you draw it down?
Yeah, this is a shift up 2. So if there was no shift and it looked like that, we'd reflect it like that, and then shift it up to 2.
Yeah.
Okay, okay, here's another chance for you to show me that you know your algebra. This is another one where it says to you, write an equation of P in terms of F, R, and N. So if you're writing an equation in terms of an equation P, that's P equals. So use correct algebra to solve for P. Wasn't this one easy? Solve for P? If I made it sound harder than it was, so maybe that's why everybody's taking so long. There's one step. Divide by 1 plus r to the n. Divide by 1 plus r to the n. There's no simplification, right? What could we do more to this? Could we do and that? That'd be breaking the most forbidden of all forbidden rules of math. Right? Do you understand that? Okay. There's nothing we can do here. Questions? I was thinking that it would have been cool to solve for n. Maybe we should do that for fun. F is equal to P and then 1 plus r raised to the n. Go, solve for n. So, get it, and n equals, yeah, this one will be good. This will be better. What you would do, so you would first say, oh, this is n, I'm solving for n, it's exponential, so I've got to isolate the base, so I divide both sides by p, the p divides out, and then you'd say I have f over p equals 1 plus r raised to the n. You'd say I'm trying to get n out of the exponent. The only way to do that is to undo it using logarithms. So I'm going to log base 1 plus r on both sides, log base 1 plus r. So that undoes that. So then n is equal to log to the base 1 plus r of f over p. You got it right? Yeah. Good job. That's what I was originally thinking just when I saw this problem that they were going to do, but they did the easy one. Okay, number 8. So you said, okay, if 74 was the mean, and then we add 6, that'd be 1 standard deviation, add 6 again. That's 2 standard deviations, and that is our 86. So then it took 2 standard deviations. Your answer would be 2. Huh? Okay, number 9. It says, what's the domain of the function? Write it as an inequality and an interval notation.
Bracket.
As an inequality, we'd say our x values are greater than or equal to -3, and then it's from -3 to infinity. Okay. Given the volume is x minus 4x plus 7, x plus 2, the height is given by x minus 4. What are the other 2 dimensions of the box when the height is 24? Right. So then the height is given by this. It says the height is equal to 24. So you'd set up a true statement. And then it says, what's the other 2 dimensions of the box? So you'd solve for x. So x equals 28. And so then the other 2 dimensions of the box would be plugging in 28. So it would be 35 and 30. 35 and 30. And then if it asked what the volume was in a separate box, then you would just times them, right? You would do 24, length times width times height, so you would just do 24 times 35 times 30 if it asked for volume. Okay, awesome. Okay, that is the last stage review problem for the day. I just want to remind you of a couple rules from secondary 2 before the bell rings for lunch. Actually, we're not going to probably, I don't know, probably not. Okay, so I want to remind you that circumference of a circle would be finding the outside distance of a full circle, 2 pi r, right? Area of a circle is pi r squared, that'd be filling it in. To find the length of an arc, we have done this year. Don't you do the radius times theta? The radius times by theta. That would give you the physical length of the arc, but doesn't theta need to be in radians? If I say give me the physical distance, I'm going to want it in radians, not 400 degrees worth, right? Next thing to remind you of, if you have, this is called a inscribed angle, I think. So if you have an inscribed angle, it has to touch the circle, and then if it opens up on an arc, this angle is literally half that amount. Way to remember. So this is 60, this would be 30. So that's just a rule you'll have to remember. If you have a central angle, that means it starts at the center of the circle and opens up on an arc. This angle is literally equal to this arc. If that's 30, this is 30. Yeah, degrees. But this is the length of the arc. If I say this is 30 degrees, we call this 30 degrees. If I say find the length of the arc, you would... Yeah, this is just the arc measure. Good. Then tangent lines to circles. A tangent line is a line that only touches the circle in one spot. So this line, you see how it touches in one spot? Yeah. It could extend out. Now, if you have a tangent line, then if you drop, this is the rule. If you have a tangent line, then if you drop a radius to the point of tangency where it touches, it will create a 90-degree angle. That's a rule you'll have to remember. So this one's touching right there, so that would create a 90-degree there. Yeah. Okay. Cool, that's what I wanted to remind you of, because that's going to be what you see on ACT Test Prep 8 as well towards the end, because I teach it in, anyways, go. Ready, set, go. I really wish you would just try to remember it.
What about the